Next, another definition of memory reference instructions are those commands or instructions which are in the custom to generate a reference to the memory and approval to a program to have an approach to the commanded information and that states as the from where the data is cached continually. Ito nga po yung sinasabi ko na 7 memory reference instructions. Ito po yung sumusunod na definition ng bawat isa. And the end instruction implements the end logic operation on the bit collection from the register and the memory word that is determined by the effective address. The result of this operation is move back to the register. So next, I will just read the definition of it because it is easy to learn. The add instruction adds the content of the memory word that is denoted by the effective address to the value of register. LDA, the LDA instruction shares the memory word denoted by the effective address to the register. STA saves the content of the register into the memory word that is defined by the effective address. The output is next to use the common bus, and the data input is linked to the bus. It needed only one micro operation. Boon, which is the branch and conditionally instruction, can send the instruction that is determined by the effective address. They understand that the address of the next instruction to be performed is held by the PC, and it should be incremented by 1 to receive the address of the next instruction in the sequence. If the control needs to implement multiple instructions that are not next in the sequence, it can execute the Boon instruction. BSA. BSA stands for branch and save return address. This instruction can branch a part of the program known as a subroutine or procedure. When this instruction is performed, BSA will store the address of the next instruction from the PC into a memory location that is determined by the effective address. And last, the ISZ, the increment if 0 instruction, increments the word determined by the effective address. If the incremented cost is 0, thus PC is incremented by 1. A negative value is saved in the memory word through the programmer. It can influence the 0 value after getting incremented repeatedly. Thus, the PC is incremented and the next instruction is skipped. And the next topic I would tackle is addressing modes, which means the different ways of specifying the location of an operand in an instruction are called addressing modes. Dito natin nalalaman yung pinaka-specific na location kung saan ang operand, kung asan yung operand sa instructions. So we are here so many types of addressing modes which are implied, implicit addressing mode, stack addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode, register and direct addressing mode, register and direct addressing mode, relative addressing mode, index addressing mode, base register addressing mode, auto increment addressing mode, auto decrement addressing mode. So apat lang po yung aking matatakal dito at yun ang direct, indirect, and register direct, register indirect. So here they are. Direct addressing mode. The address field of the instruction contains the effective address of the operand. Only one reference to memory is to fetch the operand. It is also called as absolute addressing mode. So makikita natin sa picture na nasa below, tinatawag nga itong direct addressing mode as absolute addressing mode. And kung makikita natin is yung A wherein the address fields, sinasabi dito na it is connected to the operand. Wherein, sinasabi nga dito only one reference to memory is required to fetch the operand. Kung makikita natin na yung A, it holds the address, is connected to the operand. Ibig sabihin, kahit yung address lang na connected sa operand is okay na sa memory. Yung example dito is add X, it will increment the value stored in the accumulator by the value stored at memory location X. Makikita na natin, from accumulator plus, lalagyan natin ng X, bracket, only one bracket sa X. Dito naman sa indirect addressing mode, kung sa direct addressing mode is isa lang ang kailangan na reference para ma-fetch natin yung operand. Dito naman is 2 references. Kung saan, makikita natin, in order na makakonect sa operand, kailangan natin ng address and the effective address bago tayo mag-connect sa operand. The address field of the instruction specify the address of memory location that contains the effective address of the operand. 2 references to memory are required to fetch the operand. So here is the example. Tingnan na lang po natin yung image para natin maintindihan. Ang example is add X will increment the value stored in the accumulator by the value stored at the memory location specified X. Kung single bracket lang naman nakalagay dun sa direct addressing mode, dito makikita natin sa example na sa halip na isa, it is double kasi siguro nga 2 references and from address field and to connect the effective address to the operand. Next po, register direct addressing mode. Sabi dito, the operand is contained in a register set. So kung ang kinocontain ng direct and indirect addressing mode is the memory, dito naman po sa register addressing mode, ang kinocontain niya na sinasabi dito is register set. So kung makikita natin sa baba, it is determined by register set. And sabi dito, the address field of the instruction refer to a CPU register that contains the operand. No reference to memory is required to fetch the operand. Kung dun po sana na is isa lang, dalawa, dito po is wala. Yung A, which means the address, dito naman po is nabago. Yung A is napalitan ng R, which yung R is tinutukoy bilang register set. And that nagkoconnect yun sa operand natin. Example dito is add R will increment the value stored in the accumulator with the content of register R. From the accumulator, makikita natin, accumulator, mag-add tayo ng R, single bracket, na nakapaloob yung R. And the note, dito sa register direct addressing mode is, this addressing mode is similar to direct addressing mode. Pumakita na natin sa image kanina, na it looks similar nga naman, kasi ang nagpalit lang is kung A doon sa kabila, and na nag-hold ng address, ito naman is napalitan ng R, which is nag-hold ng register. And pareho sila nakakonect agad sa operand natin. Saka ang kinocontain ng operand dun sa kabila is memory, while dito is register. Pero sa pagkakaayos ng image is similar na naman sa direct addressing mode. Next, register indirect addressing mode. Dito naman, the address field of the instruction refers to a CPU register that contains the effective address of the operand. Kung yun nga po yung tinutukoy ko, ito naman is naiba sa image ng lahat. Kasi, since yung iba, A, holds up the address, dito nga rin is register set din. Ngunit, nagko-contain siya ng effective address of the operand. And, makikita natin sa image, bago mag-connect ang effective address, bago mag-connect sa operand, kailangan muna ng effective address before be connected to the operand na nagko-contain ng memory. Makikita natin, from register, the effective address, nagko-contain dito ng register set before we be connected to the operand that nagko-contain ng memory. And here is the example. Add R will increment the value stored in the accumulator by the content of the memory location specified in register R. From accumulator, makikita natin na magiging accumulator and plus R with a double bracket inside, sa loob ng R, sa labas ng R pala. And the note naman dito, this addressing is similar to indirect addressing mode. Yun nga, ito, kung yung isa is naka-similar sa direct addressing mode, ito naman is na indirect addressing mode. The only difference is address field of the instruction refers to the CPU register.